بسم الله الرحمن الرحيم. In this lecture, we are going to speak about the dot product of two or more vectors. The dot product of two vectors, start with the definition to define what we mean by dot product. Because we have dot product and we have another type that called the vector or a cross product or cross multiplication of the vectors. Start with the definition. The dot product of two vectors A and B, say A equal to A1, A2, and B, which is equal to B1, B2, and B3, is the number given or is given by A dot B is equal to A1, B1 plus A2, B2 plus A3, B3. And you will notice that this is scalar value. The scalar value. It's just a number. It is not a vector. The dot product of two vectors will give me scalar value. It's not a vector. For example, given A is equal to 3, 4 minus 5. B is equal to 1 minus 2 and let's say 9. Then the dot product A with B is equal to will be 3 multiplied by 1, the first component with the first one, plus 4 multiplied by minus 2 plus minus 5 multiplied by 9, which is equal to 3 minus 8 minus 45. That will be minus 50. So the dot product of two vectors is scalar value. It is not a vector. For the dot product, we have some basic properties. Let's state these properties now. Of the dot product. First one, A dot B equal to 0 if A equal to 0 or B equal to 0. 2, A dot B equal to 0 equal to B dot A. For the first one, sometimes also we have another case for A dot B equal to 0 if A and B are orthogonal. So A equal to 0, it means that either A equal to 0, B equal to 0, or sometimes if they are orthogonal, and we will define this later on. 3, A dot B plus C equal to A dot B plus A dot C. 4, A dot KB equal to B dot KA equal to K multiplied by A dot B, where K is scalar. Five, A dot A equal to magnitude of A squared, which is always B greater than or equal to 0. So these are the properties for the dot product. For the dot product, we have alternative form of dot product. That is A dot B equal to magnitude of A multiplied by magnitude of B multiplied by cosine of theta, where the theta is the angle between the two vectors A and B. This is A, this is B. So the theta is the angle between the two vectors A and B. So the dot product A dot B equal to the magnitude of A multiplied by the magnitude of B multiplied by cosine theta. And this can be used to find the angle between two vectors. For example, find the angle between A, which is equal to 2I plus 3J plus K, and the vector B, which is equal to minus I plus 5J plus K. And we need to find the angle between these two vectors. So first of all, I have to find or using the formula, that is A dot B equal to magnitude of A, magnitude of B multiplied by cosine theta, or cosine theta equal to A dot B divided by magnitude of A and magnitude of B. Now A dot B, 2 times the first one with the first one, it is minus 2, plus 3 with 5 is 15, and 1 with 1, this is A dot B. A1 times B1, A2 with B2, A3 with B3. I have 2 multiplied by minus 1 is minus 2, 3 multiplied by 5 is equal to 15, and 1 multiplied by 1 is equal to 1. For the magnitude of A and magnitude of B. Magnitude of A will give me 4, the square of the component, plus 9 plus 1. Second one is 1 plus 25 plus 1. Magnitude of A equal to 14. Magnitude of B equal to 27. So this will give me theta is equal to cosine inverse of minus 2 plus 15 plus 1. That will be 14 divided by square root of 14 multiplied by square root of 27. This will give me the angle between the two vectors A and B. So this form is used to find the angle between two vectors A and B. Cosine theta equal to A dot B divided by magnitude of A multiplied by magnitude of B. Now let's speak about the orthogonal vectors. Two non-zero vectors A and B are said to be orthogonal if and only if A dot B equal to 0. A and or A dot B equal to 0. Orthogonal means perpendicular. This word, orthogonal, means theta equal to 90. So two vectors are perpendicular. If A dot B equal to 0. Let's see this one now. Take one example for the orthogonal. Find scalar C. Scalar C. So that the given vector are orthogonal. A is equal to 2i minus cj plus 3k. B equal to 3i plus 2j plus 4k. And we need to find the value of c so that the two vectors are orthogonal. So we need to find the dot product A dot B. Dot product first component with the first component. This is 6 minus c plus 2 is minus 2c plus 3 multiplied by 4 is 12. And since these are orthogonal, this must be equal to 0. So I have 6 minus 2c plus 12 equal to 0, or 18 minus 2c equal to 0. This will give me c equal to 9. So the value of c is equal to 9. If c is equal to 9, we have orthogonal vectors, or the given vectors a and b are orthogonal. So the idea is to find the dot product equated to 0, solve the given equation to find the value of c.